1. Melting ice caps could awaken dormant volcanoes. New research reveals climate feedback loops. 2. Climate crisis. Melting glaciers could trigger volcanic eruptions. 3. Melting glaciers trigger volcanoes. Scientists warn of chilling chain reaction. 4. Melting glaciers and volcanic explosions. Climate change's hidden threat. 5. Antarctica's hidden threat. Melting ice could spark hundreds of explosive volcanoes. 1. Melting ice caps could awaken dormant volcanoes. New research reveals climate feedback loops. Imagine a world where the very ice caps we're desperately trying to save might inadvertently awaken dormant volcanoes. This alarming possibility, highlighted by recent research in the Chilean Andes, adds a new layer of complexity to our understanding of global warming's far-reaching impacts. At a scientific conference in Prague, researchers presented findings suggesting that melting ice caps could trigger increased volcanic activity. This isn't just a short-term inconvenience, the long-term implications could be catastrophic. Some volcanoes in Antarctica, for example, could accelerate ice melt from beneath, while others might unleash explosive eruptions capable of sending climate-altering material into the upper atmosphere. The study, funded by the National Science Foundation, examined the chemical composition of rocks at 6 volcanoes in the Chilean Andes. By analyzing changes in the magma over thousands of years, particularly during the most recent ice age, scientists discovered that volcanic activity surged as the ice melted away. This phenomenon can be likened to uncorking a pressurized soda bottle. Once the weight is lifted, the gases trapped within are released, leading to eruptions. Brad Singer, a geoscientist from the University of Wisconsin-Madison, who led the research, explained that thick ice caps act as lids on volcanoes. When these lids melt or slide away, the volcanoes can become more active. After the glaciers retreated and the ice load diminished, we observed significant changes in both the frequency and composition of eruptions, he noted. During the last ice age, around 14,000 to 20,000 years ago, magma beneath the ice accumulated and partially crystallized, trapping gases. This buildup can result in powerful eruptions that shoot ash miles into the sky, potentially reaching the stratosphere. Singer's analogy of a soda bottle highlights the sudden release of pressure and gases once the ice cover is removed. Singer has dedicated nearly 3 decades to studying the geology and volcanic activity in the Andes. His research has shown that much of the previous focus was on post-glacial activity rather than what occurred during the peak of glaciation. Inspired by studies of eruption traces on surfaces such as ash layers in pond sediments, this latest research delves deeper into the relationship between ice loading and volcanic activity. The implications for Antarctica are particularly concerning. Beneath the vast West Antarctic ice sheet, which covers an area of 760,000 square miles, there are over 100 volcanoes. Warm ocean currents are already causing the floating ice shelves to melt from below, creating a volatile situation. There is likely a rift area in the crust underneath the thick West Antarctic ice sheet, Singer said, indicating that the interaction between ice and volcanoes could amplify the instability of both the glaciers and the volcanic activity. The removal of ice can significantly increase the frequency of eruptions, which, if occurring at the base of the ice sheets, could accelerate ice melt. Additionally, the pressure exerted by the ice influences how materials inside the volcano behave, potentially leading to more explosive eruptions when the ice melts. Previous studies in Iceland, a region with both ice and active volcanoes, have shown that subglacial eruptions release heat-trapping carbon dioxide into the atmosphere. For instance, the Katla volcano emitted between 12,000 and 24,000 metric tons of CO2 daily in 2016 and 2017, surpassing previous estimates for all of Iceland's volcanoes combined. Moreover, the weight of the water from melting ice sheets could trigger other geological feedbacks. In 2024, researchers suggested that rising sea levels due to melting continental ice sheets could increase earthquake hazards by raising hydraulic pressure. Similar processes have been observed in areas surrounding reservoirs with high water levels. David Pyle, a volcanologist from the University of Oxford, praised the new research for strengthening the evidence linking ice loading, influenced by climate change, and volcanism. However, he noted that the volcanic response may not be immediate and could vary depending on the type of volcano and its mineral composition. This discovery presents a complex and potentially negative feedback loop for the climate. Increased volcanic activity beneath thinning ice sheets could accelerate ice sheet collapse and sea level rise. While this scenario is not desirable, it underscores the interconnectedness of Earth's systems and the unpredictable consequences of global warming. In conclusion, as we continue to grapple with the challenges of climate change, it's crucial to consider all possible outcomes, including the unexpected awakening of volcanoes beneath melting ice caps. How will society respond to such developments? What measures can be taken to mitigate their impact? These are questions worth pondering as we navigate this evolving landscape. 2. Climate crisis. Melting glaciers could trigger volcanic eruptions. Imagine a world where the climate crisis doesn't just raise sea levels but also triggers volcanic chaos beneath our feet, because that's exactly what scientists are warning could happen. A groundbreaking study reveals how melting glaciers and ice caps, driven by humanity's fossil fuel addiction, might unleash a domino effect of explosive eruptions from sleeping volcanoes. But here's where it gets controversial. Could our own carbon emissions indirectly fuel even more climate chaos through these fiery giants? Let's unpack the science and the simmering debates behind this alarming discovery. When glaciers vanish, they don't just flood coastlines, they take the lid off underground magma reservoirs. This pressure release makes eruptions far more likely, a phenomenon already observed in Iceland's tectonically volatile landscape. But the real game changer. New research from Chile's Andes mountains provides the first solid evidence that continents, not just islands, face this risk. Picture this: as the last ice age ended 18,000 years ago, melting ice sheets triggered a volcanic awakening across South America. Today, West Antarctica, a land hiding at least 100 ice-covered volcanoes, could be next. And remember that Antarctic ice melt isn't a distant nightmare, recent studies confirm it's already accelerating. Here's the twist that keeps scientists up at night. While individual eruptions temporarily cool Earth by blasting sun-blocking particles skyward, sustained activity would drown our atmosphere in volcanic greenhouse gases like CO2 and methane. This creates a dangerous feedback loop. Hotter temperatures melt more ice, which triggers more eruptions, which heat the planet further. It's like a geological version of poking a bear. The more we disturb Earth's icy crust, the more violently it might respond. Let's break down the evidence. Dr. Pablo Moreno-Yager's team camped near active Andean volcanoes, analyzing rocks from Chile's Machochachuenco Peak. Using radioisotope dating, they discovered that during the Ice Age, a 1.5-kilometer thick glacier kept eruptions suppressed by acting like a giant pressure valve. But when that ice vanished 13,000 years ago, pent-up magma erupted violently, literally exploding onto the scene. Even cooler. The molten rock's chemistry changed too. Trapped pressure had forced it to absorb silica-rich crustal material, making eruptions more viscous and explosive. Think of it like shaking a soda bottle: remove the cap too fast, and everything goes everywhere. Critics might argue, so what if this happened millennia ago? Modern climate change is different. But here's the part most people miss: computer models now predict similar pressure shifts in Antarctica and other glaciated regions like Alaska's Aleutian Range. The Chilean findings align with global patterns. Volcanic activity spiked 2 to 6 times after the last ice age worldwide, and 2004 studies in California's Sierra Nevada showed identical magma responses to ice loss. Yet despite these clues, researchers admit we've barely scratched the surface of climate-volcano connections. Should we be investing billions in Antarctic volcano monitoring? Or does that distract from the urgent need to cut human-caused emissions? The stakes couldn't be higher. Moreno-Yager's work isn't just about predicting lava flows, it's about understanding how Earth's systems intertwine in unexpected ways. As glaciers retreat from Patagonia to Greenland, we might not just lose ice, we could awaken geological titans that reshape our climate future. So here's my challenge to you: when experts warn about unknown unknowns in our climate system, should we fear these volcanic wild cards as much as melting ice itself? Drop your thoughts below. This is one debate we can't afford to keep buried. 3. Melting glaciers trigger volcanoes. Scientists warn of chilling chain reaction. Imagine a world where the very ice that protects us could unleash a hidden threat beneath our feet. It's a chilling thought, isn't it? But here's where it gets controversial. Melting glaciers could trigger a chain reaction of volcanic eruptions that could affect the entire planet. You might think that ice is just frozen water, but it's much more than that. It's a natural regulator of volcanic pressure. As global temperatures rise and glaciers melt, we're not just raising sea levels, we're setting the stage for a dangerous domino effect. Take the Andes Mountains, for example. Recent research from the University of Wisconsin-Madison revealed that as ice layers diminish, the pressure on subterranean magma chambers decreases, leading to more explosive eruptions. It's like removing a cork from a bottle, except the bottle is filled with molten rock and gases. But the real source of danger lies beneath Antarctica, where over 100 volcanoes are currently covered by thick ice. As the ice melts, we're not just losing a beautiful landscape, we're potentially unleashing a massive amount of greenhouse gases that could accelerate global warming. It's a double threat. Global warming melts ice, causing volcanic eruptions, which in turn increase atmospheric heat. If we don't interrupt this cycle, it could spiral out of control. And this is the part most people miss: the effects aren't limited to one region. Countries like the US, New Zealand, Russia, and even India's Himalayan region could face similar threats. So what can we do? Scientists urge us to take these findings seriously and invest in further research to mitigate potential disasters. It's a call to action that we can't afford to ignore. What do you think? Are you concerned about the potential for volcanic eruptions triggered by melting glaciers? Let's discuss in the comments. 4. Melting glaciers and volcanic explosions. Climate change's hidden threat. Imagine a world where the thawing of ice sheets could unleash a fiery cascade of volcanic eruptions across the globe, potentially exacerbating the very climate crisis driving the melting. This isn't just a theoretical scenario, it's a finding from a recent study that has sent shockwaves through the scientific community. But here's where it gets controversial. As glaciers retreat due to climate change, the volcanoes buried beneath them may awaken, erupting more frequently and violently than ever before. Around the world, hundreds of volcanoes lie hidden beneath the vast ice sheets of Antarctica, Russia, New Zealand, and North America. These volcanoes have been suppressed for millennia by the immense weight of the ice above them. However, as global temperatures rise and these ice sheets continue to melt and recede, the pressure on these volcanic systems is being relieved, potentially leading to a dramatic increase in volcanic activity. A team of researchers presented their findings at the 2025 Goldschmidt Conference in Prague, focusing on 6 volcanoes in southern Chile. Their study, which examined the volcanic activity during the last ice age, revealed a fascinating connection between glacial retreat and increased volcanic eruptions. Lead author Pablo Moreno-Yager, a graduate student at the University of Wisconsin-Madison, explained that glaciers act like a brake on volcanic activity, but as they melt, the brakes are lifted, allowing volcanoes to erupt more often and with greater force. This phenomenon is not new to science. Back in the 1970s, scientists first proposed that melting ice could influence volcanic behavior. The mechanism is straightforward. The weight of glaciers compresses the Earth's crust and mantle, confining subterranean gases and magma. As the ice melts, this compression is reduced, leading to increased pressure within volcanic chambers and more explosive eruptions. Iceland provides a compelling case study. During the end of the last ice age, approximately 10,000 years ago, as the island's glaciers retreated, its volcanoes experienced a significant surge in activity. The eruption rate increased by 30 to 50 times compared to pre- and post-glacial periods, fundamentally altering the landscape of the country. Despite the potential risks posed by continental volcanic systems, this area remains relatively unexplored. To address this gap, the geoscientists studied the volcanic history of southern Chile, particularly focusing on the Machachahuenco volcano, which became active as the Patagonian ice sheet melted thousands of years ago. By dating volcanic ash layers and analyzing crystals formed during eruptions, the researchers were able to trace the relationship between glacial retreat and volcanic activity. Their analysis showed that between 26,000 and 18,000 years ago, during the peak of the last ice age, thick ice cover suppressed volcanic eruptions, allowing a large magma reservoir to accumulate beneath the surface. Once the ice sheet melted, the pressure in this reservoir increased, ultimately leading to the formation of the Moreno-Yager volcano. This threat is not limited to isolated regions. According to a 2020 study, 245 potentially active volcanoes worldwide lie either beneath or within 3 miles, 5 kilometers of ice. This means that as climate change continues to accelerate glacial melting, these volcanoes could pose a significant risk to global stability. Moreno-Yager emphasized that the key factors for increased volcanic explosivity include thick glacial coverage over magma chambers and the onset of glacial retreat. He highlighted regions such as Antarctica, North America, New Zealand, and Russia as areas requiring close scientific scrutiny. It's important to note that while individual volcanic eruptions can temporarily cool the planet by releasing sulfate aerosols that reflect sunlight, the long-term impact is far more concerning. Over time, the accumulation of greenhouse gases from these eruptions could accelerate climate change, creating a feedback loop where melting glaciers trigger more eruptions, and these eruptions in turn contribute to further warming and melting. This interconnectedness underscores the complexity of Earth's systems and the urgent need for comprehensive research into the potential impacts of climate change on geological processes. As we continue to witness the effects of global warming, understanding and preparing for these unexpected consequences will be crucial in shaping our future response strategies. What do you think? Should more resources be allocated to studying the relationship between glacial melting and volcanic activity? Share your thoughts in the comments below. 5. Antarctica's hidden threat. Melting ice could spark hundreds of explosive volcanoes. Antarctica is facing a hidden danger that could have far-reaching consequences. The melting ice is poised to trigger a multitude of explosive volcanoes. A recent study has unveiled a shocking connection between climate change and heightened volcanic activity, indicating that the swift melting of glaciers and ice caps, particularly in areas like West Antarctica, could lead to hundreds of volcanic eruptions around the globe. This research, which draws on geological data from the Andes Mountains in Chile, illustrates how the retreat of ice diminishes the pressure on underground magma chambers, thereby increasing the likelihood and intensity of eruptions. Scientists suspect that this phenomenon, already noted in Iceland, may be applicable to various glaciated regions worldwide. The most alarming aspect is the presence of at least 100 volcanoes concealed beneath Antarctica's thick ice. As global temperatures continue to rise, this hidden volcanic threat could create a perilous feedback loop that exacerbates climate change. The transition from ice to fire, a chain reaction occurring beneath our feet. A study presented at the Goldschmidt Geochemistry Conference in Prague highlights that glaciers play a crucial role in suppressing volcanic activity by exerting significant pressure on the magma chambers located beneath the Earth's surface. As global warming causes these glaciers to melt, this pressure is relieved, allowing gases within the magma to expand and potentially erupt with explosive force. Researchers observed that after the last ice age, regions such as Chile experienced a notable increase in volcanic activity, providing a foreboding glimpse of what might unfold as contemporary glaciers continue to vanish. Antarctica has lost an astonishing 3 trillion tons of ice since 1992, and the implications of this loss are profound. A case study from Chile's Andes. Lead researcher Pablo Moreno-Yager and his team focused their investigation on Moreno-Yager, a volcano in Chile, employing radioisotope dating techniques on volcanic rocks. Their research revealed that a thick layer of ice covering the area between 26,000 and 18,000 years ago effectively suppressed volcanic eruptions. However, once the ice melted around 13,000 years ago, the volcano began to erupt more frequently and with greater intensity. The prolonged buildup of magma underground resulted in increased viscosity, which heightened the explosiveness of the eruptions when they finally occurred. The escalating risk in Antarctica. The West Antarctic ice sheet, which is already vulnerable to rising temperatures, conceals at least 100 known volcanoes. Scientists caution that the melting of this ice could unleash significant volcanic activity in the region. While volcanic eruptions can temporarily cool the planet by releasing particles that block sunlight, sustained volcanic activity would release carbon dioxide and methane into the atmosphere, further accelerating global warming. Global implications that extend beyond Antarctica. Although much attention is directed towards Antarctica, other glaciated areas such as North America, New Zealand, and Russia may also be at risk. The findings from this research emphasize the need for scientists and policymakers to closely monitor glacial regions and prepare for potential climate volcano feedback loops. There is an urgent call for more research, which is now deemed critically important, to comprehend how rising temperatures may interact with Earth's geological systems. A call for immediate investigation. Despite the potentially enormous impact of volcanic activity, it remains an underexplored aspect in climate change models. Researchers assert that it is essential to incorporate geological responses, such as eruptions, into our understanding of climate risks. As glaciers continue to recede and reveal ancient volcanoes, the Earth's response may not be gradual or subtle, but rather loud, explosive, and globally disruptive. But here's where it gets controversial. Are we truly prepared for the consequences of these volcanic eruptions, and how will they reshape our understanding of climate change? What do you think? Share your thoughts in the comments.